Good day everyone! In this video, we will discuss about critical numbers and extrema. One application of derivatives is finding the maximum or minimum values of a function. Suppose we do not have the graph of a function and we want to find the maximum and the minimum values. It is first necessary to find the numbers x where these values occur since the function depends on x. Finding the derivative of the given function allows us to determine these numbers x, which are called critical numbers. We say that the largest and or smallest values of a function can have possibly occur at these critical numbers. By definition, let f be a function that is continuous on an open interval I containing x sub 0. We say that x sub 0 is a critical point of f if f prime of x sub 0 is equal to 0 or f prime of x sub 0 does not exist, that is, f has a corner or a cusp at x sub 0, y sub 0. The definition indicates that in order to find the critical numbers of a function, we first get the derivative of the function, then identify the values where the derivative becomes 0 or undefined. The obtained values are the critical numbers. With this, let us apply this definition in determining the critical numbers of the given function f. Suppose we have a function f of x equals 3x squared minus 3x plus 4. Note that f is differentiable everywhere. So critical points will only occur when f prime is 0. Differentiating, we get f prime of x is equal to 6x minus 3. Equating f prime to 0 and solving for the critical point, we will have f prime of x is equal to 6x minus 3, 0 is equal to 6x minus 3, 3 is equal to 6x, and dividing both sides by 6, we will get x equals 1/2, which is the critical number of the given function. Let us take another function. F of x equals x cubed minus 9x squared plus 15x minus 20. First step is to find the derivative of the function. F of x or the function is equal to x cubed minus 9x squared plus 15x minus 20. Applying the differentiation rules, we will get f prime of x is equal to 3x squared minus 18x plus 15. For the second step, equate the derivative to 0 and solve for the critical numbers. Since we have the derivative f prime of x equals 3x squared minus 18x plus 15, equating it by 0, we will have 0 equals 3x squared minus 18x plus 15. Since we have here a quadratic function which is factorable, we can factor it by 0 equals 3 quantity x squared minus 6x plus 5. X squared minus 6x plus 5 can still be factored into x minus 1 times x minus 5. Equating both factors by 0, we will get the critical numbers 1 and 5. Another example, f of x is equal to x cubed minus x squared minus x minus 10. Again, for the first step, find the derivative of the function. So we will get f prime of x to be equal to 3x squared minus 2x minus 1. Step 2, equate the derivative to 0 and solve for the critical numbers. Since we have these as our derivative, equating it by 0, we will get 0 equals 3x squared minus 2x minus 1. Again, since this is a quadratic function, we can factor the trinomial into 3x plus 1 quantity x minus 1. By equating both factors by 0, we will get the critical numbers negative 1/3 and 1. For our last example, the function is f of x equals x minus 3x raised to 1/3. Finding the derivative of the function, we will get f prime of x equals 1 minus 3 quantity 1/3 x raised to 1/3 minus 1. Simplifying it, we will get 1 minus x raised to negative 2/3. Since we have a negative exponent at x, for it to become positive, we will write it at the denominator, giving us with 1 minus 1 over x raised to 2/3. Simplifying our expression, we will get x raised to 2/3 minus 1 all over x raised to 2/3. Next, equate the derivative to 0 and solve for the critical numbers. Remember that we have solved this as the derivative of the function. Equating it to 0, we will get 0 equals x raised to 2/3 minus 1 all over x raised to 2/3. For it to become equal to 0, we can simply equate the numerator by 0. So we will have 0 equals x raised to 2/3 minus 1. So we will get 1 equals x raised to 2/3 and x is equal to 1. So we have here a critical number. However, notice that the resulting derivative is a rational function. With this, we also need to consider the value of x that will make the denominator equal to 0. Thus, notice that our denominator is x raised to 2/3. Equating it by 0, we will get x equals 0. Therefore, we will have here two critical numbers, which are 0 and 1. Knowing the critical numbers is very important in determining the maximum and the minimum values of a function. First, we define what is a maximum value. Let f be a function that is continuous on an open interval I containing x sub 0. We say that the maximum occurs at x sub 0 if the value f of x sub 0 is the largest among all other functional values on I. That is, f of x sub 0 is greater than or equal to f of x for all x in I. The definition indicates that for a certain function f, when one evaluates f at all values within the interval, say, a, b, containing x sub 0, and that f of x sub 0 is the largest among all other values, then f of x sub 0 is the maximum value of f at the interval a, b. And this value occurs when x is equal to x sub 0. On the other hand, we say that the minimum occurs at x sub 0 if the value f of x sub 0 is the smallest among all other functional values on I. That is, f of x sub 0 is less than or equal to f of x for all x in I. For the minimum value, its definition states that for a function f, when one evaluates f at all values within the interval I containing x sub 0, and it occurs that f of x sub 0 is the smallest among all other values, then f of x sub 0 is the minimum value of f at I, and this value occurs when x is equal to x sub 0. Therefore, we say that an extremum of f occurs at x sub 0 if either the maximum or the minimum value occurs at x sub 0. Note that extremum can be either a minimum or a maximum value. However, if we will be solving for both minimum and maximum values, we say that to be extrema. Let us take some examples. Find the extrema of the given functions on the interval -1, 1. Note that these functions are the same as the previous examples. Moreover, in finding the extrema of these functions, we will be showing some steps that you can follow. So let us take the example, f of x equals 3x squared minus 3x plus 4. For the step 1, get the functional values of all critical points inside -1, 1. And at the endpoints -1 and 1. Remember that earlier, we have solved that the critical number for f of x equals 3x squared minus 3x plus 4 is 1/2. So what are we going to do is we will be substituting the critical number to the function and also the endpoints of the interval -1, 1, which are -1 and 1. And we will be solving for the value of f of x. If x is equal to -1, then the value of f of x is 10. If x is equal to 1/2, then the value of f of x is 13/4. When x is equal to 1, then f of x is equal to 4. Step 2. Compare the values. The highest one is the maximum value, while the lowest one is the minimum value. Clearly, from the table, the maximum of f occurs at x equals -1 and has a value of 10. The minimum value of f occurs at x equals 1/2 and has value of 13/4. Thus, the maximum value is 10 and the minimum value is 13/4. Another example. F of x equals x cubed minus 9x squared plus 15x minus 20. Again, for the step 1, we will be substituting the critical numbers to the given function, also the endpoints of the interval -1, 1, and we will be solving for the value of f of x. Thus, we will arrive on this table. Remember that earlier, we have solved the critical numbers of this function to be -1 and 5. However, we cannot include 5 in substituting to the variable x on the given function because 5 is already beyond the interval -1, 1. Note that we can only use the critical number if it is included in the given interval. Therefore, we will just be considering -1. When x is equal to -1, the value of f of x is equal to -45. When x is equal to 1, the value of f of x is equal to -13. Comparing these values, the maximum value is -13, which occurs at x equals 1, while the minimum value is -45, which occurs at x equals -1. Let us take this example. The function is f of x equals x cubed minus x squared minus x minus 10. Recall that the critical numbers of this function are -1 and -1/3. Since both critical numbers are within the interval -1 and 1, then we will be using both critical numbers in substituting to the variable x. When x is equal to -1, the value of f of x is equal to -11. When x is equal to -1/3, the value of f of x is -25/27. When x is equal to 1, then f of x is equal to -11. By comparing the values, notice that the maximum point is -1/3, -25/27, which makes -25/27 be the maximum value, while the minimum points are 1, -11, and -1, -11, which makes the minimum value to be -11. For our last example, remember that the critical numbers are 1 and 0. Since 1 and 0 are both in the interval -1, 1, then we will be substituting -1, 0, and 1 to the variable x of the function. Evaluating the values of f of x, we will get 2, 0, and -2 respectively. Comparing the values, we will get the maximum point to be at -1, 2, which makes 2 as the maximum value, while the minimum point is at 1, -2, which makes -2 to be the minimum value. I hope that you have understood the lesson. For our next video, we will discuss about optimization. Thank you so much for listening and see you on our next video.